Hello, class. Actually, I put that out like 2 minutes ago, but I'll try to remember that as we're working through this. And I think I'm going to pull that a little further forward so that we can still see the bottom of the page. What we want to do now, and what we got through the last time, is we went through the mesh analysis and we ended up getting the 3x3 matrix that we now want to do the determinant for and figure out what the determinant is for the base. Because to find out the individual currents, I1, I2, or I3, we're going to have to take the solutions column and then exchange it with each one of those and then solve the matrix for that. But let's do the first one because that's got to go on the denominator of whatever we're solving for, right? So let's just do this. It'll give us a little experience working with this anyway. So this is going to be 11. Now I've got minus 10 times minus 23, which gives me positive 230 minus 25. So 230 minus 25. So that would be 205. Does everybody see that? Plus 3. Now, 5 times 8 is 40 minus 69. 40 minus 69 is going to be minus 29. Right? And the last one, 8, and then 3 times 5 is 15, minus a minus 80. So I've got 80 plus 15 is 95, right? So if we do that, I'll just punch this in instead of trying to, we all know how to add, subtract, multiply, and divide. It's not like I have to do that for you. So I've got 11 times 205, and that gives me minus 2255, right? Plus 3 times a minus 29, and that gives me minus 87 plus 8 times, now is that 95? Let me do 15. Yep. So 8 times 95, that gives me 760. So you can see that this matrix that's going to be in the denominator of all three of our solution fractions is going to be 760 minus 87 minus 2255 gives me minus 1582. All right, that's the denominator of all of our things. So let's say that I wanted to find I1. I think that I actually called it small I1, but you know what I mean. Now I would take the solutions column and I would replace the first column with that. So that would give me the 3x3 matrix minus 15, 0, 0, 3, minus 10, 5, 8, 5, minus 23. Right? So now what we have to do, and of course to find that, we have to put that over our minus 1582 because that was our original 3x3 matrix, right? This is how we do mesh analysis. So if I wanted to do this, I would have 15 times this. So let's just write those. I don't want to get ahead of you. I don't want to lose anybody. Times minus 10, 5, 5 minus 23, right? So minus that plus, and now we want the 3. And if we look at that, that'll be 5, 0, minus 23, 0. So 5, 0, minus 23, 0. I think everybody can see that'll be an interesting matrix, right? And then we want to do the 8. So it's going to be 8, and then that's going to be 0 minus 10, 0, 5. All right. Well, let's solve that then. The first one is the interesting one, though, isn't it? Minus 15, and I got minus 10 times minus 23. That's 230 minus 25, so that's 205, right? And the next one, well, let's see, 5 times 0, I'll do that one, 0, minus 23 times 0, so that's 0, plus 8, 0 times 5, that's 0, minus 0 times minus 10, that's 0, so that's 0, 0, 0, right? So what I really have is minus 15 times 205. And that gives me minus 3,075. So I1, right? And I1, I believe, was this one. Let's draw I1, 2, and 3. I1 is here. I2, I3. Right, so I3, I2, and I1. Those are our 3 different loops. 1, 2, 3. So those are our 3 different loops. And so now we know what I1 is going to be, because we know it's minus 3075 divided by minus 1582. And of course, the minuses are going to cancel out. So 3075 divided by 1582 gives me 1.944 amps. All right. I just want to make sure that that actually, I don't know if I solved for that one. But I'm pretty sure that's right. But I'm going to do I2 now. And like I said before, I called it a small 2. So what we're going to do is we're going to take the original 3 by 3 matrix, minus 11, 3, 8. Now we're going to take I2 column, and we're going to exchange that 1500 for that column, and still keep the 8, 5, minus 23 for the third column. That's going to be on top. And of course, on bottom is going to be the minus 1582. All right, so let's do this. So I've got minus 11, and then that's going to be, well, I'll draw it out. 0, 5, 0, minus 23. I'd rather do it than lose people. Minus 15, and that's going to be the 5, 0, minus 23, 0. Oh no, that's 8. What am I talking about? 5, 3, 8, or 5, 3, minus 23, 8. That's what our thing's going to be. And then let's do the last one. So plus 8, and then that's going to be 3080. Okay. So I think everyone can 0 times that, 0 minus 0, that's gone. 3 times 0 minus 8 times 0, that's gone. So the only thing we really have is minus 15, 5 times 8, which is 40, minus a minus 69. So 40 plus 69 is 109, right? So minus 15 times 109. And of course, on bottom, that's going to be the minus 1582. So 15 times 109 divided by 1582 gives me 1.03. 0338. amps. All right. Let's do, so that's I2, and then let's do I3. And actually, the only one I solved for before was I3, so this should tell me right now if I've done everything right. So what we want to do is replace the third column now. So I've got 11, 3, 8, and then the second column is 3, minus 10, 5. And then the third column is going to be my minus 15, 0, 0. Right? And then all of that over the minus 1582 that we have at bottom. So 11, and then we're going to have this. I think that by now everybody can see that if I have the two zeros there, it's going to be 0. I'm still going to do it. Minus 11 times minus 10, 0, 5, 0. It's going to be 0. Do the second one now. So I've got 3, right? So plus 3. And then let's do that. So that's be 0, 3, and then 0, 8, right? Which also is going to go to 0. Plus minus 15, right, times 3, minus 10, 8, and 5, right? So that's 0, that's 0, minus 15. Let's see, 3 times 5 is 15, minus a minus 80. So 80 plus 15 is 95. So minus 15 times 95, all divided by our minus 1582. And let's just see what that is. So 15 times 95 divided by 1582 gives me 0.9007 amps. Well, it looks like I've done something wrong here because I just looked at my solution. That doesn't look right. I may have to redo this whole lecture. But let me take a break here and see what if I have done something wrong. Just a second. Okay, I'm back. And, you know, I'm so happy that it worked out this way because the other things are all fine. The only thing that I did here, I'm just going to circle this, and I'm going to circle it with a big red pen. There you go. Yeah, and you probably noticed it too as I was working through here. I don't always look at the stuff that I've already done solved the problem with, but it's a minor problem. 5 times 8 is 40. And then minus a minus 69. Now I did it correctly down here, but I didn't do it correctly up here. Of course, that was 109, and this should be 109 right here. This shouldn't be minus 29. It should be positive 109. And that's going to change this too, isn't it? Because instead of this being minus 87, which, you know, is wrong. And if we were in class, you'd say, hey, well, Professor Grenquist, no, you're supposed to add 69, not subtract 69 or whatever, right? So I know you would have said that. So 3 times 109 is 327, and it's positive, right? So this should be a, let's cross that out. This should be a plus 327. And so what that would adding these together would be 1,087, right? So 2250, so 1,087 minus 2255 gives me minus, right, minus 1168. All right, so these should be minus 1168, and that's going to solve all of this. Minus 1168 minus 1168. And that is going to change these two, right? So I'm going to give you the correct things right now. So 3075 divided by 1168 is 2.63. So 2.63 amps is what it should have been. And then this one, 15 times 109 divided by 1168 comes to 1.4 amps. Okay, for I2, for I1, and then I3 is going to be 15 times 95 divided by 1168, and that should come to 1.22 amps. All right, there you go. We've done the mesh analysis for the entire thing. And what I really would like to do is the super mesh. I don't know if I really have a lot of time for that super mesh, but you know, super mesh is not that important anyway. But I would certainly like to at least introduce you to the super mesh, and that we took a little more time to do mesh analysis so that you could see how to do it with 3x3, and that's really, you know, required. Is important. So like I say, the next thing that I wanted to do was super mesh, and super mesh, like super node, is where I have mostly voltage sources, but then I also have some a current source in there. And so I want to look at an example, just a little example that actually has some voltage sources and some current sources. So this has got quite a few, you know, little resistors in here. It has a current source in the center, right? More resistors, and then it's going to have another voltage source down here. Both of these two voltage sources are going to be tied into ground. That's a ground right there. And I forgot to include that line all the way down there. Now let me give you some, so this is 6 ohms. This is 20 volts. This is 12 volts. And this is 2 ohms and 6 amps flowing down. That's an arrow going down from that node right there. I'll call that node A, right? And so now what we want to do, the procedure for mesh analysis is remove current source, replace with open circuit. Remember how we replaced the voltage source when we were talking about super node? We replaced the voltage source with a short circuit. Well, right here, what we're going to do is we're going to replace the current source with an open circuit. So this is now going to become this. Right? And there you go. We've still got our 20 volts there. We've still got our 12 volts there. Got all of that. Oh, I forgot my 6 ohm resistor here. So we've still got the 6 ohm. Oh, you know, I forgot to tell you what that was. That was a 4 ohm resistor. So we've still got the 6 ohm resistor here, the 4 ohm resistor there, the 2 ohm resistor there. Still got our supplies. And originally we wanted to set up our two different, right? So when we had the original circuit, we were saying, well, this is going to be current I1, this is going to be current I2, and then we're taking that out of there. And now what we want to do, now that we've replaced that, now we still know, right, that there's going to be a difference in current between node A, right? I'll still put node A there. There's going to be a difference in current between that, right? So that's what we do. And then what we want to do is we want to look at the larger. So what I'm going to do now is I'm going to look at the super mesh, right? That's really a super mesh because it's taking in 2 mesh circles, isn't it? It's taken in both 1 and 2 as a super mesh. And so when I was when I sum the things going around that mesh, wouldn't that be plus 20 volts, right? So plus 20 volts because I'm popping from the minus to the positive there, and then minus 6 ohms times I, right? Minus 4 ohms times I, minus 2 ohms times I, and then as I keep going there, it's going to be plus 12 volts, right? All of that equals 0. Can we, can we add or subtract anything else? Sure. How about 20 plus 12? Doesn't that give me 32 volts? How about minus 6? So 32 volts equals minus 6, minus 4, minus 2. That equals minus 12. Take the minus, throw it on the other side, and that gives me 12 ohms times I, or I equals 32 divided by 12, right? 32 divided by 12 is 2.667 amps. Right? I'm just going to put, right, equals I. I think I may have gone over too far. I'm going to continue this super mesh on the next one. I'm going to finish it very quickly, and then we're going to go into the next lecture. All right, because I think I've gone. My timer is way off, so I think I've gone maybe a bit too long here. All right, see you at the next lecture.